Hello, everyone, and welcome to RAG Time. This is the place where we explore retrieval-augmented generation, or RAG. In the previous episode, we learned the fundamentals of knowledge retrieval systems. So, Matt, what are we going to talk about today?
Thanks for the intro. So my name is Matt. I am a program manager on Azure Search, and today I'm here to talk to you about building the ultimate retrieval system for RAG with Nitya.
Awesome. But first, we actually have a special interview segment with Amy and Vinod, and they're going to talk about Azure AI Search roadmap and innovation in retrieval systems. Take it away, Amy.
Hi, everyone. I'm Amy, and today we've got something really exciting lined up for you. Are you interested in building the ultimate retrieval system for your generative AI apps? And do you want to know what's next in AI-powered retrieval? Then this is going to be a treat. So joining me is someone who's deeply involved in shaping the future of Azure AI Search. So please welcome Vinod. Welcome. Thanks so much for joining us. It's a real pleasure to have you here speaking with us. Can you tell us a little bit about who you are and what you do as work?
Sure. Great to be here. I'm very excited to talk about retrieval augmented generation and a lot of other things. So my name is Vinod, and I lead the product team for Azure AI Search, as well as our Azure AI Services products, and some things like our specialized models for content understanding, speech, and so on. I started my career at Microsoft a long time ago, did a bunch of different startups and so on, and then recently rejoined Microsoft about a year ago, just because I was so excited about this whole space. So.
Very, very exciting. It's so good to hear it comes from that passion area of the technology. So I'm sure you're going to show that to all of our audience here in this interview. So there's so much happening right now, not just in the search space, but actually, obviously, the whole AI space all up. And your product, Azure AI Search, is growing and evolving in really exciting ways. Can you share at all with our audience, what's on the horizon? What are the big themes that are going on in the search sort of retrieval space?
Sure. Yeah. So search is kind of one of these classic computer, maybe on the history side, search is one of these classic computer science domains, right? It's been around 40 or 50 years in some ways. For most of the last 20 years, the big story in search has basically been web search. What is Bing or what is Google doing to give me better access to web content? Maybe about 3 or 4 years ago, this whole large language models thing appeared, and has been this incredible dynamic environment. And it introduced a big new killer use case for search, which is retrieval augmented generation. Basically, how do you take an LLM and feed it private enterprise data to get it to customize behaviors based on your own internal needs or internal data? The LLM and RAG story, I think, is still evolving. We think there's almost every week there's some new interesting research paper about new techniques and new approaches to RAG. And then the big thing that's on the horizon, of course, is agents. And so we're not too far from a world where agents become as big, if not a bigger consumer of search and RAG content than humans. And so that kind of changes the game yet again for what does it mean to build a search system or a RAG system that's optimal for delivering content to agents.
Very interesting. So yes, agents is the hot topic, isn't it, for 2025? So very relevant, but that adds complexity in some ways as well. So is that something your team are kind of looking at? How do we get quality out of so many different types of agents and stuff like that?
Oh yeah. No, it's complexity, and it's a whole new vista of new opportunities and so on. So for example, one of the features that we announced at our last trade show or last conference at Ignite is something we call query rewriting, which is basically a step towards this agentic idea. And in query rewriting, what happens is we take the query or the prompt that was given to us by a user, we rewrite that query, up to 10, 20 different ways, spawn off 10 or 20 different search processes, come back with 10 or 20 times the results potentially, and then use additional language models to go through all of these results from all these different variations of the query, package up the content, and then return it back to the LLM. And so even within the retrieval augmented pipeline, we're starting to see agentic behavior penetrating and kind of drastically changing the way search works and the way search delivers relevant results to an end user. I think that's just a taste of some of the other things that are to come, right? As agents become a more and bigger piece of the search equation.
Yeah, there are still people out there who are getting started with RAG, but RAG is incredibly popular as a way to look at it. So it's interesting to hear almost that explore, exploit type part of computer science there as well, where it's like
exactly.
10 different explorations, find the best of which, you never know where the lowest gradient is, etc. So yeah, very interesting to see that kind of come up in your space.
Yeah, and I'm glad you brought that up. I think that is, like, what an agent is still kind of a fuzzy thing, right? I think there's still, the market is still trying to figure out exactly what agents are. And one of the places where all these different agent definitions kind of overlap is this kind of notion of, well, an agent is able to more cheaply explore 50 different variations or 100 different variations or eventually thousands of different variations of a problem. And then, it might take it minutes or 30 minutes or an hour or whatever. But that's still much, much, much cheaper than a horde of research interns or, the months and weeks and years potentially that humans would have to spend. And so that idea that an agent is able to fan out and do a lot more exploration and then come back and synthesize that content together is kind of one of these central ideas and central opportunities.
Nice. And so that feature that you released, that's semantic ranking. Is that what it's called for?
It's a combination of ranking plus query rewrite. And so that's a feature that we released. So that's a feature we released just a few months ago. And that is kind of the first step in kind of this broader evolution towards agentic search and agentic RAG.
Wonderful. And so, yeah, that's a key area in that sort of innovation in retrieval. Is there any other elements that you're kind of looking at, maybe even more future ahead?
Oh, of course. Yeah, I mean, there's several different parts to the search equation. One of the most fundamental parts, and this is true not just for search, but for almost all of artificial intelligence, is basically knowledge representation or data representation, which is basically, you give me a picture or you give me a document, and 90% of the time that picture or that document or whatever that object was you gave me was designed for human consumption. And so as a human, I'm looking at a document or looking at a picture and I'm processing the picture at different levels, say, oh, that's a picture of a dog, or no, that's actually a picture of a dog chasing a car, and so on. All those different layers and all those different levels of meaning have to be encoded in a way that a computer can now go off and process. And a lot of, one of the big wins of artificial intelligence in the last, say, decade or so is the mass market availability of embeddings. And so search and content representation kind of went from this period where, maybe 30 to 40 years of the problem was how do you do different text representations and how do you understand root words versus the difference between run and running, and big tables of synonyms like jeans versus pants versus Levi's and so on. That kind of evolved into semantic understanding, AI-based embeddings and so on. And I think we're still going to see additional forms of representations around the corner. Microsoft, for example, has made quite a bit of noise around graph representations or graph RAG. More classic structured data representation. So looking at an invoice not as a document, but rather as a JSON, and so on.
Yeah. Wonderful. It's really exciting to hear. And it always sounds in the AI space like the research is so close to the product nowadays as well. Like, something comes out, a research paper comes out, all of a sudden we see people starting to try to implement it. So we can see that excitement here too. Speaking of more of those people who end up going, okay, we like this, we've experimented with it, now we want to put it into production. Azure is a very enterprise-ready cloud. How does Azure AI Search look at enterprise readiness?
Certainly. So we, maybe at the most foundational layer, there's all the classic enterprise guarantees around safety, security, privacy, control of your data, logging, analytics, and so on. And so those are kind of non-negotiable fundamental building blocks and promises that every Azure product or every Azure service is kind of, has to meet those guarantees before it's even allowed into the market. Search kind of then, from that kind of baseline or that kind of core platform capabilities baseline, search has a bunch of different angles that we go after. When people come into search or when our customers use search, there's a very, very wide spread of customer capabilities or customer intents when they're coming in. Like some customers want just a black box product where I turn it on, flip a switch, and it just goes, and now I suddenly got a search interface. The other end of the spectrum, we have customers who expect every single knob and dial and want to bring their own embedding models or want to implement their own, be able to tweak ranking models and so on. And so we've got this big spread in capabilities in terms of how people want to deploy and use search, and we end up providing features inside of our product across the full spectrum. We also have, one of the more interesting evolutions also is we have quite a few users now where search is something that gets attached to some of their other bigger workloads. And so search as something that they access from inside of Copilot Studio, or search as something that they access from inside of AI Foundry and so on. And so this idea that Search is both a standalone product with a ton of knobs and dials, and is also something that's available inside these other workbenches or these other spaces where you're performing other tasks, is kind of a big evolution for our product.
Nice. And that makes it even easier, right? If people are, if our audience are already using Fabric or Copilot, etc., that's all out there for you. It's not kind of a separate piece sitting off in Azure and having to do the setup there. So that's incredible to hear. And obviously just making more things more available.
Well, and I think it's part of the evolution of AI in general. Like AI started life as something that you went to the AI, and it was something that you had to go specifically kind of intentionally say, I want to go engage with the AI, to AI starting to just percolate inside of every single product, every single surface. I think search, and especially the RAG use case, is kind of hot on those heels. It is going to similar, every place AI starts popping up, you're going to start seeing search and RAG pop up.
Nice. Well, that's good. It's a good hint out to everyone watching as well. Keep an eye on what's happening in these spaces, because they do progress so very quickly over time as well. Well, unfortunately, we don't have all day to talk, although I probably could ask you so many more questions. It's been such an insightful conversation. I was wondering, is there anything you want to share with the audience on sort of getting started? Any final thoughts of using search and information retrieval?
Oh, sure. I mean, the fastest way to get started, as I mentioned, a big part of our strategy moving forward is to bring search into these environments where users are already doing work. And so there are tens of millions of customers, for example, who are on GitHub and a lot of our professional development tools. One of the things we recently announced is that every single GitHub user gets access to the Azure Model Catalog. And so from within GitHub, without going anywhere else, you have free access to GPT-4o and all the latest foundation models. And you now have access to a free instance of Azure Search. And so you can go there, get started, no signups, and get an idea of how this stuff works and get access to all the cool features. Things like semantic ranking and query rewriting and so on are in that fully capable version of Search.
Wow, for free? All of that
for limited capacity, but yeah, it gets you started.
It gets you started, right? And that's what developers want. We want to be able to just get in there and use it, and then decide, how much further we want to go into those proof of concepts. So that is fantastic to hear. If anyone wants to go and check that out, head over to GitHub Models to go and see that new RAG and search experience in there. With that fantastic advice, Vinod, thank you so much for being here and sharing all of your insights so thoroughly and quickly with us. But now it's time to dive deeper into building the ultimate retrieval system for RAG. So over to Nitya and Matt.
And we're back. That was a really insightful discussion into knowledge and retrieval systems and where they're headed next. But Matt, you promised to teach us how to build the ultimate RAG system. Where do we start?
Yeah, absolutely. Let's take a look at building the ultimate retrieval system for RAG. Before we get started, though, I want to point out that all the samples and documentation we're going to go over today are available in our repo at aka.mss ragtime, or you can scan the QR code below. So we're going to cover the following points. We're going to start off with data ingestion approaches. Basically, how do I get my data into my RAG system? We're going to cover the basics of keyword and vector search. We're going to talk about why hybrid search is the best of both worlds. And finally, how semantic ranker and query writing allow you to get the most out of your RAG system.
Oh, excellent. So everything actually starts with getting data into our system. So tell me more about data ingestion.
Yeah, absolutely. Let's start there. So let's talk about data ingestion approaches. So the simplest way to get started with data ingestion in Azure AI Search is to use the built-in integrated vectorization feature. Supports a variety of data sources on Azure, such as blob storage, SQL, Cosmos DB. Automatically tracks any changes to these data sources so you can make sure you're up to date. Supports cracking a variety of file formats so you can perform RAG on PDFs, Office documents, JSON files. Automatically handles some of the details of data ingestion for RAG, specifically how do I chunk, how do I vectorize my data, and how do I actually put it into my AI search index.
So this is actually interesting because it means we automate a bunch of these if you're using this in Azure, which means all my other sources in Azure can also get data into the system. This is cool.
That's absolutely right. So if you want to kind of customize your data ingestion process, here's how we typically start. Azure Blob Storage is a pretty flexible place to put documents. Typically, when we talk about RAG, we're really focused on this like unstructured document scenario, but the databases we talked about earlier support more structured RAG. We can use a service like Azure Document Intelligence to actually get the data out of all my PDFs and Office documents into a common format, get all the text out of the images. There might be scans of contracts, financial documents, anything else you can imagine. We can use a programming language like Python to take care of the chunking aspect of RAG, of kind of splitting it into smaller chunks so that we can do better RAG. We can use Azure OpenAI to turn those chunks into vectors so we can have better search for RAG. And then finally, we put it in Azure AI Search so we can actually do the retrieval.
This flow makes perfect sense, but I'm curious, why do we need to split the data into chunks?
Yeah, that's a great question. Let's talk about it. So one of the core reasons why we need to split documents is a limitation of LLMs. LLMs have something called a context window, which is basically how many documents they can look at the same time. Studies have been done, such as the Lost in the Middle study, which basically shows that when you put all the documents into the language model, its ability to do RAG decreases. So the optimal amount of documents you want to send is around 5 or potentially even less. So by having the ultimate retrieval system for RAG, you actually improve the quality.
Oh, that's excellent. So what's the optimal size for a document chunk?
Great question. We did our own study, and what we basically found is that smaller chunks are good, but in particular, you want to make sure that when you chunk documents, you actually introduce the concept of overlap, or basically adding content from the previous chunk into the next chunk. The reason for this is that when you do RAG, context of where a chunk in the document was matters. So when you're looking at these little snippets of the documents, you don't want to lose your place. There might be relevant content like table headers, or a paragraph might qualify the next one. So making sure your chunk boundaries and the number of tokens in your chunks are right is really important. And using a tool like integrated vectorization allows you to get this right directly out of the box.
I didn't realize there was this much complexity in just bringing data into the system. So this is cool. But now we've got our data in and we've created our indexes. What are our options for search?
Yeah, that's a great question. So let's start off by talking about keyword and vector search. So when we talk about search, one of the most basic techniques you can do, and one that's surprisingly effective, is actually keyword-based search. So essentially, the way keyword search works is it makes a giant list of all the terms in the document. In this example, I have documents that consist of fruit names. I basically break them down by the types of fruit, how often they occur, and which documents they occur in. So I can really efficiently search this keyword search index to find the most relevant documents, just based on the text itself.
So it's actually effective if I had search terms that were relevant to keywords in the text, but people, when they ask questions, kind of use other ways to look for things. Are there similarity-based solutions we can use?
Yeah, absolutely. As we covered in previous RAG time, we can use vectors to dramatically enhance the quality of our search. Rather than searching literal words, we can actually turn phrases such as dog, or like, I walk my dog down the street, into a list of numbers. And this list of numbers really represents the actual meaning behind the phrase. And we can take this meaning and store it directly in a vector database like AI Search and search it to enhance the quality of our RAG. The table below kind of shows how there are different embedding models, or basically ways you can turn these phrases into lists of numbers. And the Azure OpenAI models like text embedding 3 large are getting really good scores on benchmarks like the massive text embedding benchmark, which means they're very good for RAG.
So how does the user's query get matched onto these embeddings?
Yeah, that's a great question. Essentially, what we do is we interpret these giant lists of numbers as vectors, and we basically compute the angle between these vectors using a formula called cosine similarity. Azure AI Search basically takes care of computing this cosine similarity at scale over millions of documents really efficiently, so you can get really fast and effective vector search.
So vector similarity sounds cool. So how does vector search work?
Yeah, that's a great question. Essentially, we take the vector embedding for the query, and we take the vector embedding for all those chunks we computed during the ingestion process, and we basically find the best matches for it. And AI Search allows you to search every single vector in the database one by one, or using a really fast approximation that's very quick. And it's really key to kind of why AI Search is a great retrieval system for RAG. In these example, we have two examples of basically just saying like, hey, you have the word tortoise, you take a query embedding and you say, hey, this is similar to snake and frog.
So great. With this, I can get similarity-based matches. And with keyword search, I get exact matches. So I can use them together, right?
Exactly. So let's talk about hybrid search and why it's a bit different than those previous things we talked about. So we can take our keyword search, and keyword search is going to be really effective at searching for things like, imagine I'm looking for my flight, and flight numbers are typically like letters and numbers, or I'm searching for a phone number. It can be very difficult to take a meaningful vector embedding for these things and find similar things. Like I might be looking for like a number in a sea of numbers. We want to take the strengths of vector similarity, which is kind of this like fuzzy matching over like phrases and like similarity between words. We want to take the strength of keyword matching, of matching like codes, product names, flight numbers. We want to merge them together to get the best possible results using a process called reciprocal rank fusion, or RRF. By combining these two strategies together, we get the best of both worlds and a better retrieval system for RAG.
I love this. This makes our life as developers really, really easy. But from what I understand, this gives us back a whole bunch of matching results, right? So is there a way for us to optimize what results we're going to use finally in our solution?
Yeah, that's a great question. When we talk about which makes AI search the ultimate retrieval system, we really got to talk about semantic ranker and query rewriting. So when I run a hybrid query, what underwater activities can I do in the Bahamas? I start off with my keyword results and my vector results. I take both of these and I merge them together using this reciprocal rank fusion process we just talked about. But then I can even improve these results further by using the same technology that powers the Bing search engine. We're going to re-rank these search results based on how relevant they would be in like a regular Bing query. And many times what we find is that you take hybrid search and the gain on top of that for RAG is significant when you re-rank them. Semantic ranker basically takes a second look and says, are these hybrid search results really the most relevant? And it basically promotes results that hybrid search might not have thought was relevant for RAG to the top of your list. So you really make sure that the top documents your language model is seeing are the best for RAG.
This re-ranking is actually super powerful because you were mentioning we have a limited context window too. So if I can only get so many results in, I get the best ones right on top.
Exactly. I can even use the re-ranker score. So sometimes it can be really difficult to interpret cosine similarity, keyword search scores, meaningful way. The semantic ranker score normalizes these scores from 0 to 4. 0 being not a good document for RAG and 4 being the best document for RAG. So using some really simple Python code, I can basically threshold the documents I'm sending to my language model so I can simultaneously save money by sending less documents to the language model while also improving my RAG quality.
It's actually a much better user experience as well. Are there any other optimizations we can do?
Yeah, absolutely. So let's talk about query rewriting. So sometimes when I write a query, I don't necessarily know the right words to use. Vector search helps with this because we find the semantic meaning of the query, but we can do it a little bit better. We can actually generate some other potential keywords that are a good fit for this query. Like if I'm searching for underwater activities, maybe there's a keyword document about scuba diving that wasn't picked up by the hybrid search. But if we just rewrote the query a couple times, using a similar generative model to ChatGPT, we can actually find these relevant keywords and surface documents we might otherwise have missed.
I love this because we're actually getting the system to help us optimize stuff without the developer having to always be involved in the loop. So is there a way we could kind of maybe see a demo of some of this stuff?
Yeah, absolutely. So let's get back to the code. So we're going to load some environment variables. Before this, I actually set up a search service and a search index. And I used a sample document that talks about a fictitious organization called Contoso, which uses Azure and has a global deployment. So it basically talks about how are they using Azure successfully for their business. So let's call some code. So it's super simple to set up an API client for Azure Search. All I have to do is create something called a search client. So once I do that, it's literally one line of code. I've written some other code, but really the only purpose is to display search results. So we're not going to talk too much about it. So let's get into the searching. So I want to start off by just doing a plain keyword search. So all I need to do is specify my query, and I'm going to say, what is Contoso? I want to select 5 results, and I only care about 2 fields. The title of the document I'm searching using RAG, and this chunk or this kind of like little section of the document that I'm actually going to do RAG on. So when I display these results, all I get is I get the PDF that the document came from, and I'm going to get some of the characters. I'm going to look at this at search.score. This represents the keyword score. And as we talked about earlier, this might be a little hard to interpret. It's not normalized between 0 and 4 like semantic re-ranker score. Now let's do a vector search. So when we talk about vector search, Azure AI Search actually makes it super easy to do vector queries. If you set up your index with what we call a vectorizer, which is essentially a connection directly to Azure OpenAI, I don't need to worry about creating a vector embedding myself. I simply ask in the vector queries object, hey, create a vectorizable text query with the same text. There's a couple parameters I can control. This k nearest neighbors basically says, hey, how many other neighboring chunks or basically like sections of the document do I look at when I do vector search? And I have the same exact parameters. I want to look at the top 5 results, and I want to make sure I'm looking at the right fields. So when I display the results, I get slightly better. A fictional but representative global organization, which is exactly what I said before. Now let's put everything together and let's do hybrid search. Hybrid search is really as simple as just putting keyword and vector search together. So when I run this, I get something very similar. I know that Contoso is in Paris. They have satellite offices. They're a fictional representative global organization. So we can already see the RAG quality starting to climb here. Now let's take it to the next level by adding semantic ranker. I'm going to keep all my search parameters exactly the same, but I'm just going to add this extra query type parameter called semantic. When I use semantic ranker, I have the option to configure which fields are used for semantic ranking. I've pre-created a configuration that uses these title and chunk fields to basically re-rank the documents according to how this model from Bing thinks they fit the query. So now we're going to see semantic ranker thinks this document that talks about this fictional representative global organization is a really good fit for RAG. And it found a couple other options, which are still good, but this is really the best one. So we're already seeing the value of using the ultimate retrieval system. Adding query writing is as simple as adding 2 additional parameters. We basically opt into query writing by saying query writes are generative. We're going to generate some potential other candidate queries. And we're also going to make sure it knows our query is in English. So again, run it. Basically same exact query, just some extra parameters. And again, we see the fictional representative global organization floating to the top. So super easy to use everything I talked about today, just as simple as adding a couple parameters, but it's never been simpler to get started with RAG using AI search.
Okay, Azure AI Search is amazing. So to recap, like literally in the space of 15 minutes, we were able to figure out how to ingest our data, set up our indexes, run a hybrid search, which has both keyword and vector search, and do semantic ranking and query writing to improve the relevance of our results. And everything done within Azure AI Search with just a few lines of code, right?
Yeah, awesome. I think it's really cool. And like, I'm super excited to go build a RAG app on top of Azure AI Search now.
So don't forget to go check that out. And stick around for a very short Doodle-based summary of what you just learned in this episode today. And next week, you'll be meeting up 2 more of our team as we get into how you can scale your vector indexes with Azure AI Search. Thanks for watching.
Thanks so much.
Let's recap what we learned about in building the ultimate RAG system. Building the ultimate retrieval system for RAG starts with data ingestion and ends with relevance optimization. Integrated vectorization means that Azure AI Search can streamline the data ingestion in the cloud using built-in skills. And the resulting data ingestion process is customizable, from document upload to data extraction and chunking to vectorization and indexing. Data chunking helps optimize retrieval for large language models, context windows, with chunking algorithms to set the optimal size. Keyword search looks for exact text matches, while vector search looks for matches by semantic similarity. Vector search relies on vector embeddings to encode text data, then finds the closest matches by cosine similarity between the index and query vectors. Hybrid search combines both approaches with RRF, reciprocal rank fusion, allowing it to score and prioritize results. Semantic ranking and query rewriting enable relevance optimization of scored results to improve effectiveness.